So now that we know the two types of objects, references and snapshots, that we can get back from the Firestore library, let's actually talk about the structure of our database on Firestore. So let's go back to Firestore and let's look at our collections. So we only have one collection right now, our users collection. If we look at our users collection and we look at how this database looks, we can almost see that this collection of users is like an object. There is this key of users that points to this object that contains these key IDs that point to the actual value of an object that contains the document information. This is almost identical to our shop data. If you look at it, our shop data is an object that has these keys of these category names that point to these objects that hold the values of these actual categories. Now, this is by no means a coincidence. Firebase is what's considered a NoSQL database. The NoSQL database is different from a SQL database because of the way that it can store data. We'll talk about SQL databases more in a later lesson, as well as how they differ from NoSQL databases. But let's first explore NoSQL databases because we're using Firestore right now. Now, just like our JSON objects inside of our front end, they can have any number of properties and values. Our user documents right now have the same properties and the same values as each other, in the sense that both documents have a created at, a display name, and an email property. But it doesn't have to be the case. We can make a new user document that has completely different fields from the other objects. This one can have a name where the value can say Yihua. It can even have an address value that says, let's say, Toronto. Our object is still a user document object, but it's different from the other user documents inside of the collection. This becomes troublesome because on our front end, if we get all these documents, we might not know that these values are different. But the advantage is that you're able to have these really flexible documents that can store any properties, right? Regardless of what the actual conflict on the front end will be. We'll explore that later as well. But that's just one thing to keep in mind, is that when we're using a NoSQL database, we have to make sure that we enforce ourselves to store the same values across our documents if we can, because we don't want to pull in all of our users and iterate through them only to find that some objects don't have properties that we expect them to have. Beyond that, the other thing to keep in mind is what types of properties we can store. Now, let's look at what types of properties we can actually store on documents. So here we can see that we can add a field, as we did earlier, and this is the field name, and this is the type that this field expects the value to be. So we can have strings, numbers, booleans, and then we see here maps. Maps you can pretty much see as JSON objects, and we would prefer to store a list of things as maps because, as we saw with our data normalization course, that it's easier for the Firestore database to find specific elements inside of a list by the property name or the key, rather than just searching through an array for what the element is, which is the same reason why we switched our shop data from an array to an object. Arrays are not actually arrays inside of Firestore. They're maps, except the index is the key. So the first element has a key of 0, the second has a key of 1, the third a key of 2, and so on and so forth. So they're kind of like maps that resemble arrays, and we'll explore those later. You don't have to get too caught up in them. There's null, there's timestamp, which is like a date object, and then there's geopoint, which is kind of like a coordinate, but we don't have to worry about these two. We'll probably also not use them. So those are the types of properties we can store. Now, what we want to do is we actually want to add in our collection from our code base, because manually adding a collection and adding all the documents and the fields is going to be extremely tedious for this huge object that we have here. So what we'll do is we'll actually make a new util for it. And we'll make a util that we can see ourselves using again in the future. So what we'll call our util is export const add collection and items. And what it will take is a collection name, or we can call it collection key. And then we can say for the objects that we want to add in, let's call it objects to add, which can be an array. Now, inside of our function, what we're going to do is we are going to create the collection using the collection key. So we will get back a collection ref from firestore.collection and then passing in our collection key. And if you remember, Firebase will give us back a ref object no matter what. And this is great for us because using this collection ref, we don't actually have to manually make one in the database. Firebase will make this collection ref object for us. And then if we start adding elements to it as documents, then Firebase will start creating both the collection and the documents inside of Firestore. In fact, let's actually rename our function to add collection and documents, because that's where we're adding documents, not items. Now, what we need to do is we need to call our add collection and documents function somewhere in our app where we have access to the shop data. Now, we can get access by passing the data in through a selector, but we do want to only fire this function one time. So let's do it in our app because our app only mounts once. And after we've updated our data in our Firestore, we're going to remove this code because we only want to add it programmatically, right? We're just adding our shop data to our backend one time so we don't have to write it out by hand in our Firestore. So what we'll do is we will actually bring in our selector from Redux. So let's bring it in from our Redux folder, shop, and our shop selectors. And then we need our select collections for preview, and also our new function, add collection and documents. So now that we have these imported in, let's put this in our map state to props as the collections array. And what we'll do is we will destructure our collections array from our props and pass it into our new function. So what we'll need is the key, which is collections, and our collections array. And now if we look inside of our console, we'll see our collections reference where the ID points to collections. But we'll also see in our Crown Firebase that if we refresh, we won't see the collection, which is exactly what we want because we haven't instantiated any documents in it, so the reference doesn't truly point to anything real in the database yet. And now that we have our collection ref, we need to actually add these objects into this collection. And we'll do it in the next video because this video is getting a little bit long. So I'll see you guys in the next video.